Hi, everyone. Welcome to our talk, Triaging Real-time Security Threats with eBPF-powered observability. Slightly a handful to say. I'm going to start the talk by talking about my favorite subject, which is us. OK, a little bit about me. My name is Daniel Kim. I'm a senior developer advocate at New Relic. I love Hot Pot. I love spicy talks. I love spicy tweets. I like anything spicy. So if you want to follow me after the conference, follow me on Twitter at @LearnWithDaniel. Who are you, Robert?
Yep, I can take it over from here. So as Daniel alluded to, I am Robert. I'm an application security engineer at New Relic. I like big mountains, much like Daniel. I really enjoy spicy food. And it kind of goes hand in hand with all the spicy security incidents that I love dealing with as well. Spice is a little different, but it's still spicy. I'm active pretty much in the bug bounty and CTF scenes, so those are always a lot of fun. I'm a huge nerd about low-level implementation, so if you want to talk about assembly, I'll say I'm happy to talk about it, but it's happy with an asterisk. It's assembly after all. So I'll pass it back to Daniel. He can talk about our agenda, and then we'll dive deeper into this.
Yeah, so we have a really packed agenda for us today. We're going to first start off by talking about what incident command looks like at New Relic, how we handled the critical Log4j vulnerabilities, limitations we faced with traditional observability, and we're going to also talk about cutting-edge real-time monitoring solutions via eBPF, and also the lessons learned after we went through the whole ordeal.
Yep. So thanks for that, Daniel. I'll take over, and I'm first going to talk about, as previously said, incident command and how it kind of functions at New Relic. So obviously, we have a dedicated security team. We are the Teenage Mutant Ninja Turtles, maybe. And so we are dealing with a lot of complex issues where we have to mitigate and remediate. Obviously, there's a lot going on, so of course we're hiring. Security is kind of blowing up right now, which is great. But I'll dive into what more we do in a little depth. So obviously, we need to prevent vulnerabilities and provide kind of a security education to our developers. And so how we do that, we're performing threat models, we do our own independent research, as well as security reviews directly with those teams. But that's more on the prevention side. Obviously, that's only one side of the house. We need to be able to kind of rapidly respond to new and emerging threats, and so that's kind of the responsive side. So we need to have a balance between those two. And to kind of mitigate those or prevent them from happening in the first place, we try to define standards and policies, all that fun stuff. But really, I want to dive into what are the incidents that we're dealing with. Well, just plainly put, no idea. I'm serious. We don't actually know what incidents we're going to be dealing with. If we knew about them in the first place, I would have loved to solve the security problem before it got into production. So obviously, very similar to kind of how SREs work, we're in a very chaotic incident. So usually a security incident's happening, you need to be pretty quick. You need to basically figure out what an attacker is doing. And obviously, with an incident you don't know about, speed is kind of the name of the game. So we have to really be able to enable security engineers to dive into a service that they may not know about, like at a core functionality level, and still be able to mitigate the problem and really to stop an attacker in his tracks. So you have to be parity with what the intended behavior of your service is, as well as what an attacker is doing to kind of abuse that behavior. So how do we do that? Well, we kind of have to make big decisions when we go into an incident. So we have a very kind of hierarchical structure. We'll have an incident commander. This should all be pretty kind of normal stuff. We have to do risk assessment across many different kind of areas within security. So obviously we have cloud security, we have application security, legal and compliance get thrown in there, data privacy, and all that nice jazz. So we need to be able to realize tangible threats and obviously untangible threats. And so when we're making decisions, we need to be kind of informed by data. You don't want to make an assumption for what an attacker is doing. You want to know right away, hey, this is what their behavior is, this is what we're seeing. But you need to also understand, an attacker is trying to trick you. They are taking behavior and they're kind of manipulating it in a way that is malicious, nefarious, kind of hidden behind closed doors. So you need to verify it. So you got to be able to put your hat on and say, hey, is that actually what's happening? So we always say trust but verify. And code doesn't lie. An attacker may mask behind it, but at the end of the day, it will not. So in our incident response, we kind of have these three pillars of let's first understand what's happening. Let's know what services are affected. What is the kind of situation we're dealing with? And then, of course, we want to fix things. We want to patch the vulnerability. We want to stop an attacker. You want to stem the bleed really quickly. However, that's just understanding what was occurring. you need to then assess, hey, what did an attacker do? What did they exploit? Was any of our data kind of impacted? And how does this affect the business? So there's two sides of the house of saying, hey, let's stop an attacker, but also be able to understand what he's doing. And so to kind of really put this into concrete terms, we're going to look at Log4j. And if you're not aware of it, it was a huge kind of security incident that dropped in December. It affected a large portion of the tech world. If you're using Java and you were logging things, there's a high probability you're using Log4j. So I don't want to talk too much about the actual vulnerability details. Really what I want to focus on is the impact. So with Log4j, some of the core problems that we saw is remote code execution. Those words, they're intended to be very scary. They keep a security engineer up at night. With remote code execution, really, you're giving an attacker the ability to execute malicious code. We're giving them a lot of freedom to move about. So I roughly translate it as it's the worst thing that can happen. We're giving the attacker essentially SSH access to your host, and from there they can move, left, right, escalate their privileges horizontally or vertically. You're giving them a lot of flexibility, and with flexibility, they can again try to trick you, hide their behavior, and really do some nasty stuff. So when you're thinking about what an attacker can do, what you're doing is you're kind of assessing the impact. So you're going to put on your little hackerman hat, and you're going to threat model what would be the worst case scenario. And before you start doing that, you need to understand how your application is fitting into your infrastructure, into your deployment process. What are the privileges that your application is running in? If it's running as root, well, those security engineers are also not going to have a very happy day because you're giving, again, more privileges for an attacker. And so it may be a little trivial to assess this on one service. So you can just say, hey, our login service is affected by Log4j. But when you're scaling this up to hundreds, thousands of applications, you really begin to see the toil of saying, hey, we're going to have a human go look at logs, go look at all of our services. As the name of Log4j implies, we are looking at logs. So when you say, hey, this is a very widespread incident, where do we begin looking? You're going to want to start looking at logs, but just gathering that data and looking at it, you're not really deriving value from it. If you're saying, hey, we're going to scale this to 100, thousands of applications, you can't really just say, security engineer, go look at all those logs, tell me what an attacker is doing. So really, you got to be careful about gathering data, but also keep in mind deriving actual value from it. And kind of along that vein, you need to also be able to prove, is a service unaffected? It's very easy sometimes to see, hey, an attacker is in our login service, they're doing some nefarious things. That's easy to prove. But what if there's an attacker who's kind of hiding his steps, hiding his footprint, and you want to be able to say, hey, our login service is affected, but our logging service is unaffected. So those are difficult questions to answer. And so when we first started dealing with Log4j, we kind of focused on traditional observability. And I'll talk about the limitations of that as I continue to go on, but first I'll just kind of break down what we were looking at in the first place. So obviously with Log4j, we're looking at Java applications. We're going to start first just looking at the raw jar information and the virtual machine. So one of the mitigations for Log4j was a certain flag you can set in your JVM for one of the CVEs, not for all of them, unfortunately. So we have to be able to kind of point where are our services, where do we need to be looking at? And then with this traditional observability, you get what I kind of refer to as if then that observability. If you get an incoming HTTP request, then you're going to make a span, you're going to make a metric, you're going to have this kind of logic, and that's going to get sent somewhere. It's going to get sent back to a collector, wherever it's going. So you know kind of what's happening. There's a standard flow. You're able to really know what your agents are doing. But that comes with a caveat. With this really rigid data collection, you get what you get, and you can't be upset. But unfortunately, sometimes you do get to be a little upset because you can't go back and add new instrumentation as an attacker is kind of exploiting your system. I can't say to the attacker, hey, can you stop for an hour? I want to add more instrumentation so I know what you're doing. You really got to be able to be you got to go with the punches for an attacker. So the rigidness is kind of a small caveat. And you can't just go back and change your source code. Obviously, there's normal developers flows that you need to go through. So it's very difficult to, on the fly, adjust your instrumentation to what an attacker is doing. And this kind of comes with a caveat of they're static and they're predictable. And with a rise of obviously a lot of open source instrumentation, an attacker can go read what your agents are doing exactly. At New Relic, we open source all of our agents. You can go read exactly what we're collecting, where we are looking. And what this presents for an attacker is they know where your observability is going to have gaps. They're going to know, hey, if we're not looking at DNS data, maybe I should try to exfiltrate kind of secrets through that avenue. So it presents a kind of a tricky situation where an attacker can kind of plan and then execute on that plan and know exactly where to hide and where to kind of trick your observability. So it's really an interesting situation that security gets put in. So when I kind of imagine this, you kind of have this web where you have these bad guys, they're touching your applications, they're trying to exploit something. But as I've kind of alluded to before, they know where to hide or they know where to mask their behavior. So it may appear that they're doing something, but you may miss it. And if you miss something, it's not the greatest situation. I like to say like the unseen threat is the deadliest. So if you don't know what is happening, you don't know how to start assessing the impact, but more importantly, you don't even know how to stop it as it's going on. So when you're looking at the application layer, you're kind of giving the ability for an attacker to kind of masquerade, hide his footsteps. And so you really have to think like, how do they exploit that? So I'm gonna walk through kind of a scary scenario with you. So let's just say evil.com, that's gonna represent our attacker. And we have our super secure server. Obviously, if you name it super secure, it's going to be secure. So just within the context of Log4j, let's say we have a incoming HTTP call to say, hey, let's exploit something over JD&I. Well, there's going to be some back and forth handling with some LDAP communications to make sure there's malicious code getting executed. That's the CVE details of a lot of Log4j. We won't dive into that, but if you look at the square at the bottom left, that's really where an attacker is getting the ability to execute code. So I kind of like to refer to it as they get to pop a shell. We're giving them this flexibility, and let's just say in this scenario, they're able to collect all of your customers' social security numbers. Obviously, that's not a great situation. The IRS might not be too happy. I don't think your customers will be too happy as well. But once they've kind of aggregated all this sensitive information, they're going to know what your observability is looking at. They're going to know, oh, wow, we're monitoring HTTP. Let's try to trick this a bit and send data over DNS, which is kind of a weird thing to do. Obviously, DNS is not meant for data communications. It's more just for resolving host names to IPs. But if you start to put on your attacker hat, well, why can't we just prepend the root domain with social security numbers? Scale this up to every single person's 10,000 DNS requests. Well, that's 10,000 social security numbers that we just sent back to evil.com. And if you're not looking at DNS, you're really going to miss that. And how are you going to be able to really judge the impact if you missed the crucial piece of they sent data back? So that's always a very scary thing. So how do you fix that? Well, as I've kind of implied before, you really want to start looking at the kernel. The kernel is very difficult to trick. You're not going to give an attacker a lot of flexibility and a lot of movement. Really, it's a nice source of truth to say, hey, when we're operating system, it's going to interact with our hardware. That's a very stable, it's a well-documented kind of infrastructure. So you're not going to be able to trick it too much. So that's where you want to be able to look both at your application from the security side as well as the kernel, so you can really dig away from that kind of masquerading that an attacker might do. And so how do we do that? Well, I'll kind of pass it over to Daniel, and he'll kind of break it down how we actually look at the kernel.
Yeah, thanks, Robert. So far we went over a lot about New Relic security, incident response, and kind of the limitations of traditional observability. So I'm super excited to introduce Pixie, which is a CNCF open source project dedicated to kind of translating a lot of that kernel information into actual usable observability platform data. So Pixie is like a platform where you can actually turn a lot of that kernel level insights into actual things that you can use at your job. So here's the problem that I think Pixie is solving. So there's a lot of tools that are both open source and closed source to observe in your system. So whether it's like the CPU, memory, file system, networking, containers, applications, et cetera, et cetera. However, it's really hard to turn all of this information into usable information. And it's also hard to collect all of it and instrument everything to make sure that you're actually gathering all the information you need. So eBPF is a cool technology that I think solves a lot of the issues that we have. So it allows applications like Pixie to see what's going inside black box applications because it allows sandbox user applications to run in the Linux kernel. So this allows us to get a lot of data without having to tinker with the source code itself. So think monitoring without having to instrument your applications with agents. It's agentless monitoring. So in traditional observability, we're missing a lot of the deeper things that are happening behind the scenes, like syscalls. So if you're missing something in your instrumentation, you're kind of screwed. But with eBPF, if you need more data, you can script something to gather the data you need. So with eBPF as a unifying framework for gathering data, you as an application developer or an SRE can actually gather performance data at the same time and the same way as a security engineer can use it to track malicious attacks on an application. So you can always script and add instrumentation to your existing application without having to change anything in production. So it's really cool. So here are some ways that you can see if some bad actor has exploited a vulnerability with Pixie. So in that evil.com example, the hacker was using DNS to actually send social security information to its own server. So you can actually use Pixie to see every single raw DNS query going in and out of your system. So if you're going to reach out to an attacker's web server in evil.com, it needs to resolve the evil.com domain into an IP address when they're sending data. So to do that, you need a DNS query to turn evil.com into an IP. So it will be logged in Pixie, so you can actually see if an attacker is using that method to send data to their server. You can't really trick DNS, so if they're using a DNS server, Pixie will definitely catch it. Another cool script that Pixie has out of the box is tracking and tracing HTTP requests. So you can think of HTTP requests as like the entrance. So in order for an attacker to exploit log4j remotely somewhere, they're going to initiate most likely an HTTP request. And Pixie gives raw HTTP queries made to any part of your system. And because it uses eBPF to get this data, it's virtually impossible to trick or mask. Another cool feature, there's a lot of cool features of Pixie, is a flame graph. So it shows the exact calling stack for a particular process. So let's say you're triaging an incident and a person has exploited a vulnerability. You want to see exactly where things went awry and what happened before and after. So the flame graph will show exactly what part of the stack the vulnerability was exploited and more context to the overall attack. So this is a screenshot of actually the flame graph in Pixie, where you can actually see the various functions that is being called to address a particular request. Cool. Another cool feature is the net flow graph. So the net flow graph is really important to show how attackers are attacking other services within your same environment. So this is important to judge to see if your attacker is moving laterally across your services. So let's say we see a line between the login service to a service it's not supposed to be talking to. So why is this service talking to things that I did not program it to do? So it shows exactly how your services are communicating both internally and externally. So it shows similar information to the DNS visualization that we went over a couple slides ago, but it's an actual visualization, not a database. You can also see what services are talking internally within your system, so you can see how attackers are moving laterally within your particular environment. So if you see a particular service talking to an IP that's not in the same country, that's obviously a really, really big red flag. Another cool process is another cool feature of Pixie is that you can actually trace processes. So with remote code execution, attackers are going to try to bring their own tooling, which means they're going to essentially have SSH access into your server. Robert calls it popping a shell. Then they're going to start running a bunch of nefarious stuff in your system to see how they can escalate privileges, collect data, hide their tracks, et cetera, et cetera. So when you actually start a new process, like for example, when an attacker wants to start sending data back to evil.com, Pixie will actually capture this process and the command line arguments that were used to run that particular piece of code. So if we see a process we don't recognize, that's a huge red flag. So we need to figure out who started that process, where's that process running, what arguments it has. So we basically want to use that to figure out what's going on. And one of my favorite features, we actually have a really cool blog on this in the New Relic blog, is detecting SQL injections. So with Pixie, you can monitor raw MySQL and Postgres queries, which allows security engineers like Robert to quickly assess SQL injection attempts. And when an attack is actually successful, they can know exactly the database queries that were run and exactly what was returned by that query. So this removes the guesswork when dealing with data breaches or similar type of events when you have accidentally exposed customer and internal data that wasn't supposed to be revealed. So here you can see the individual raw database queries that were made in the bottom half of the screenshot. And you can also see the latency and throughput and other golden signals related to how your system connects to your database. So yeah, those are some of the cool features of Pixie that you can leverage to see if an attacker did bad stuff with your application. So here are a couple of lessons that we have learned by leveraging both traditional and dynamic observability while dealing with Log4j. So traditional monitoring allows businesses to quickly know where to focus their efforts to mitigate and patch an ongoing attack. So you can think of traditional APM as the looking glass that guides you to solve the problem eventually. Dynamic observability, on the other hand, allows you to get data on the fly through scripts to fit whatever you need. So frameworks like eBPF and Pixie allow engineers to use scripts to get the data they need, whether they are a security engineer or an SRE, just like everyone here. Together with both traditional and dynamic observability, you can get a full picture of what is going on in your environment to get as low level, like think IP packets, or as high level, think service maps, as you need to solve your particular issue. So yeah, Robert, what are some of your lessons learned?
Yep, I would love to talk about that. So for me, the kind of melding of your traditional and dynamic observability, it kind of represents a nice paradigm shift because you no longer have to take assumptions as to what an attacker is doing. You're going to be able to know exactly the steps that they took. You can look at the first entrance at the HTTP call. You can then see, hey, what processes they were running, kind of all the steps that Daniel just talked about in the slides before. You no longer need that guesswork. You can see at the very low level kernel implementations, you can see system calls getting run. So you take the guesswork out, which is, to me, really, really awesome. But importantly, it's scriptable and it's flexible enough to where the lessons that you've learned in a past incident, you're able to directly apply those to an incident that may occur in the future. You know, if the next Log4j pops up, well, we already know, we have the scripts ready, we have the kind of knowledge to know, hey, let's go look at our incoming and external connections. Let's go look at what processes were spun up in the last 24 hours. So we know all these kind of lessons and we're able to apply them quite quickly. So instead of kind of saying, hey, we have an incident, let's start to spend a lot of time in that understanding portion that I talked about before, you kind of speed that up a ton. And as I've kind of alluded to before, you get continuous monitoring of successful attempts. So we've been talking about an attacker successfully exploiting a system, but unsuccessful attempts are also extremely important. You're able to kind of profile what is happening, what is the kind of public kind of pressure on your services, even at an unsuccessful level. And that'll kind of point you to maybe we should put a higher priority for security work on those areas that are quite popular. And when you take the assumptions out and you're able to know what is successful, what is unsuccessful, you can kind of give a clear risk assessment to your leadership and say, hey, we know for a fact that we were unaffected because we have all this supporting data, or you have this supporting data to say the opposite. And to kind of tie this with how does this relate to kind of reliability? Well, a security incident inherently means there's something kind of unreliable happening. An attacker is exploiting something. It's not great, and it does not happen on your schedule. As much as I would love to go tell an attacker I'm taking vacation this week, you can't really do that. So when you really have these incidents, you need to be able to kind of be quick, but you can't, as I've said, give up on thoroughness. Because when you start giving up on that, that's when you have to make assumptions and have guesswork. So kind of speed is the name of the game, but if you're sacrificing knowing the ability to assess an attacker's impact, you're really losing a crucial piece of the puzzle. So with that, I will hand it back to you, Daniel, and then we can kind of wrap things up.
Yeah, so before we wrap up, I kind of wanted to summarize a couple of things that I've seen, not just in our talk, but like throughout the rest of the conference. So something that I've seen in the talk right before ours and other talks is that security and reliability go hand in hand. You can't have a reliable system that's not secure. And I think it's really important to apply and kind of realize all of the really cool tooling that's coming out in observability and how we can leverage that both to make systems more secure, like our talk talked about, but also how we make systems more reliable. Because more data and more accurate data that is more applicable to our situations always makes our lives a lot easier as both SREs and security professionals. And yeah, eBPF I think is a really cool up and coming technology that can hopefully get us more data that can help us do better at our jobs. So I want to say thank you for coming to our talk. If you thought we were cool, come to the new Relic booth downstairs. We have some swag, and we also have a small demo of Pixie if you want to see how this actually works in real life. And yeah, thank you.